Imagine a tough medical case, a real mystery. You've got two different, devastating brain diseases that look so much alike they can fool even the most experienced doctors. I mean, the symptoms are confusing, they overlap, and getting a clear diagnosis, it's incredibly difficult. Well, today we're going to crack that case. We're going to solve the puzzle of how to tell these two conditions apart, and we're going to do it by focusing on one single fascinating clue: the way a person moves. Okay, so let's meet our two suspects. On one hand, we have cortical basal degeneration, or CBD. On the other, progressive supranuclear palsy, or PSP. And the reason they're so hard to tell apart? Just look at this. They share features at pretty much every level. We're talking about the underlying changes in the brain, the clinical signs a doctor sees, everything. But most importantly for our story today, they both cause major problems with movement. It's this overlap that creates a kind of diagnostic fog. Now, the central clue here, the one thing that connects both of these diseases, is a symptom called apraxia. And what's so wild about apraxia is that it isn't about muscle weakness. A person has all the physical strength they need. They want to make the movement, but there's this disconnect. It's like the brain's how-to manual for doing things, simple stuff like waving goodbye or using a key, has just gone haywire. That's the symptom we really need to dig into. So this leads us to the big question, right? If this key symptom, apraxia, shows up in both CBD and PSP, then how on earth can it help us tell them apart? It honestly sounds like a dead end. But here's the twist. As we're about to find out, the answer isn't if apraxia is there, but how it's there. To figure this out, researchers knew they couldn't just rely on what they saw day to day. No, they needed a really precise scientific plan to hunt for the subtle differences that everyone was missing. So they designed an investigation to put the apraxia from both diseases right under the microscope. So here's how they set it up. First, they got their groups together. One group with CBD, one with PSP, and a healthy control group for comparison. Now, this next part is super important. They matched the CBD and PSP patients based on their level of disability. That way, they knew they were comparing apples to apples. Then, they brought out their secret weapon, a special diagnostic tool called the Dorenzi Ideomotor Apraxia Test, which is designed specifically to pick up on these movement planning mistakes. And this is where it starts to get really fascinating. The investigation started paying off, and the very first clue they found was a big one. It wasn't just about if patients were making mistakes, it was about how many of them were struggling in the first place. So let's just look at the raw numbers. The test revealed a really stark difference. Almost 71% of the patients with CBD showed signs of apraxia. But for the PSP patients, that number was way down at 36%. So right off the bat, we've got a numbers-based clue. Apraxia is almost twice as common in CBD. That's a huge first step in telling them apart. But here's where the real detective work kicks in. The numbers, how often the errors happened, that was just the tip of the iceberg. The researchers started to realize that the most important clue wasn't in the quantity of mistakes, but in the quality, the actual kind of mistakes each group was making. That was the real key. And this table just lays it out perfectly. For the CBD patients, their biggest problem was a kind of fundamental awkwardness or clumsiness. I mean, even really simple one-step gestures were a struggle. But the PSP patients had a totally different problem. Their main issue was with sequencing. They could do the individual actions okay, but they'd get the order all mixed up, especially when the task had multiple steps. So what do we have? We've got two completely different error patterns, clumsiness on one side and jumbled up sequences on the other. So what does that tell us? Well, it suggests that even though we call the symptom apraxia in both cases, it's actually being caused by two different kinds of breakdowns inside the brain's movement-making machinery. And it turns out, these two error patterns actually have names, and this is the absolute key to the whole thing. The clumsiness that you see in CBD, that's a classic sign of what's called limb kinetic apraxia. It's a problem with the fine, precise control of your limbs. And those sequence errors in PSP, that's ideal motor apraxia, which is a problem with planning out the sequence of a movement in the first place. Let me put it another way. In CBD, what seems to be happening is a breakdown in the brain's ability to control how the muscles are activated. The brain knows exactly what it wants to do, but the signal to do it with any kind of precision gets all staticky and distorted, and the result? Those clumsy, awkward movements. But in PSP, the glitch happens a step earlier. The problem there is a breakdown in activating the right motor program to begin with. So the individual parts of a movement might be fine, but the brain is essentially grabbing the pages of the instruction manual out of order. So there we have it. The puzzle is solved. But you might be wondering, okay, so what? Why is this actually important? Well, this discovery has a huge real-world impact, not just for doctors trying to make a tough call, but for our basic understanding of how the brain controls every single thing we do. All right, so let's just quickly recap what we've learned by cracking this case. First, apraxia in these two diseases is not the same thing at all. It's different in both how often it shows up and what it actually looks like. CBD is all about that limb-kinetic apraxia, that clumsiness. And PSP, when apraxia is present, it's more likely to be ideomotor, a sequencing problem. And maybe most importantly, this shows us that a pretty straightforward test, like the Ditarenzi, can be an incredibly powerful tool for telling them apart. And that kind of leaves us with one final amazing thought. This whole investigation, this whole breakthrough, it all came down to just carefully watching how people performed a few simple gestures. And if one little test of movement can reveal such profound differences in how the brain is working in two really complex diseases, well, it just makes you wonder, doesn't it? What other secrets about the hidden workings of our brain are just sitting there, waiting to be revealed by the things we do every day?